All right, let's get into it. Today, we're going to crack the code on a massive 17-mark GCSE chemistry question, all about the Haber process. What we're going to do is go way beyond just the basic facts. We are going to deconstruct this thing piece by piece to show you exactly what the examiners are looking for to give you every single one of those marks. Okay, so here's our game plan. We'll start by looking at the question itself. Then we'll break it down, hitting the raw materials, atom economy, and how to separate the ammonia. After that, we're going to tackle the data and plotting a graph before we dive into the big one, that 6-marker on the conditions. And finally, we'll unlock the secrets of the mark scheme itself. So, this is it, the big one. Question 07 from an AQA paper. This is a huge 17-mark challenge that's all about producing ammonia. So let's break it down and tackle it together. All right, let's kick things off with the first couple of parts. These are all about testing your core knowledge of the Haber process. 2 little questions with a nice 3 marks up for grabs. So, first up for 2 marks, give the sources of the nitrogen and of the hydrogen used in the Haber process. Pretty straightforward recall question, this one. Just take a moment. Where do these 2 vital gases actually come from? Now check this out. This is straight from the official mark scheme. For nitrogen, the answer is air, simple enough, but they'll also accept atmosphere. And for hydrogen, the main answer is natural gas. But look at the other options. You could have also said methane, or even water/steam. Knowing these alternatives can be a real game changer. Okay, on to 07.2, just a single mark, but it's a really crucial concept. How does the equation for the reaction show that the atom economy of the forward reaction is 100%? This is all about understanding a core principle in chemistry. And you know what? The answer could not be any simpler. The mark scheme gives you the full mark for this one, direct phrase. There is only one product. That is literally it. Because ammonia is the only thing you make in the forward reaction, no atoms are wasted. That means you get a perfect 100% atom economy. Easy mark! Right, let's see how this all builds up. The next question, 07.3, takes us from chemical theory to the more practical side of things, separation. So the exam gives you this simplified diagram. You've got your reactants going in, they zip through the reactor, and then the whole mix of products and unreacted gases goes into this box labeled X. For this next question, our entire focus is on what is happening inside that box. And the question is, explain how the ammonia produced is separated from the unreacted nitrogen and hydrogen in X. So it's basically asking for the specific method. How do you actually get the pure ammonia out from the stuff that didn't react? And the answer is a classic 2-step process worth 2 marks. First mark, you say the mixture is cooled. The second mark comes from explaining what happens because of that cooling. Only the ammonia liquefies, or as the mark scheme also says, condenses. The nitrogen and hydrogen stay as gases, because their boiling points are way, way lower. And just like that, they're separated. Okay, time to switch gears completely. Question 074 isn't about your chemistry knowledge, it's all about your data handling and graphing skills. And with 4 marks on the line, this is a pretty big deal. So here is the data they give you. It's a simple table, just showing you what happens to the percentage yield of ammonia as you ramp up the pressure. As you can see, when the pressure goes up, so does the yield. And here is your canvas. The exam paper gives you the axes, and they've even given you a little head start by plotting the first 2 points. Your job is to finish it off. So let's talk about where these 4 marks come from, because this is super important. You get 1 whole mark just for correctly labeling the scale on the x-axis. Then you get a whopping 2 marks for plotting all 5 of the other points correctly. And that last mark, the one so many people forget, that's for drawing a smooth line of best fit. Seriously, don't just connect the dots with a ruler. It needs to be a curve. We're on the home stretch now. This is the final and, let's be honest, the toughest part of the question. Here you have to use that graph you just drew and then pull everything you know together for the big 6-marker. Okay, so for question 07.5, you have to use your new graph. It asks you to figure out the yield at 500 atmospheres, which, you'll notice, isn't in the table. The marks here come from physically showing that you're extending or extrapolating your line on the graph, and then reading the value off the y-axis correctly. And here it is, the moment we've been building up to. Question 07.6, the 6-mark beast. Explain why these conditions, 450 degrees Celsius, 200 atm, iron catalyst, are chosen for economical production of ammonia. This question is all about one word: compromise.
Now, this table is gold. This is what the mark scheme calls indicative content. It's not a checklist where you have to say these exact words, but it shows the examiner the kind of things a great answer should have. You need to talk about temperature, pressure, and the catalyst, and for each one, you've got to consider how it affects the speed of the reaction, where the equilibrium lies, and of course, the cost.
So how do you actually get all 6 marks? It's not about just listing facts. That's a level 1 answer, maybe 1 or 2 marks. To get into the middle, for level 2, you start linking some of those ideas together. But to hit that top level, for 5 or 6 marks, you have to identify all the key points and logically link them together to tell a clear story. A detailed account that fully explains the compromise between a good yield, a fast reaction, and keeping the costs from going through the roof.
Whew, we made it all the way through. So, after breaking down that 17-mark monster, what is the big takeaway here? What have we really learned?
I mean, just think about it. This one single question tested a massive range of skills. It started with simple recall of facts. Then it made you apply principles like atom economy. It tested your practical data skills, your graph skills, and then to top it all off, it asked you to bring multiple complex ideas together into one big, coherent explanation. It's like a full workout for your brain. So, after all that, what's the ultimate exam strategy we can pull from this deep dive? And it all comes down to this. The secret to success isn't just knowing your chemistry, but knowing exactly how that chemistry is marked. Understanding the mark scheme, just like we've done here, isn't something you do after an exam to see where you went wrong. It is one of the most powerful tools you can use to prepare before you even set foot in that exam hall.